All right, good afternoon, boys and girls. So we are going to be starting section 5.4, which is graphing polynomial functions. And first things first, in order for you to understand today's lesson, we need to fill out this chart and the chart in back of that, or the next page, this one. And it'll make things a lot easier because you'll probably have to refer to those. Or even if you don't refer to those, understanding these charts will help you with today's assignment, okay? So to kind of speed this up, I'm going to show you how to fill out this chart, and filling out the second chart will make things a lot easier, okay? If you use a graphing calculator and you graph these, it'll make things easier, okay? But I'm going to give you some basic tips. Okay, so let's start off with some basics. The equation y equals x is the one that you graphed many times in integrated one, and that's a linear equation. Okay, so when you graph it, you should be graphing a line. Y equals x squared, you also had some time to practice it in integrated one, but we've been practicing in this class so far, and that's quadratic. Okay, y equals x cubed is cubic, and we've been practicing in our class so far. And then the ones we have not practiced are y equals x to the power of 4, and that's called a quartic. Think of a quarter, okay? And y equals x to the 5th, that's called a quintic. And then anything after that, we just call it by its exponent. So for example, y equals x to 6, we just say 6-degree polynomial function. And what we call a degree is basically the exponent. So if we have y equals x to the 7th, then it would be 7th-degree polynomial function, and so on, okay? So anything after that. Okay, so first of all, you need to know the name of the equation. And remember, all of these are the positive ones. So we're all going to start with positive. So if you have a graphing calculator, it makes it easier to understand what these graphs look like. If you don't have a graphing calculator, you can use Desmos. And also, I'll be giving you some hints, okay? So let's get started. All right, so the graph of y equals x basically looks like this. Let me use my marker. Basically looks like a line going this way. Again, remember, we read them like we read a book from left to right, so it should be rising. And it's just a line, okay? Y equals x squared, that's a parabola or a U shape, and if it's positive, it's moving up, okay? I compare every function to these two, and there is a correlation. Okay, so ready? You're going to see this one. A cubic function basically looks like this. Okay, let me move this a little bit. So now let me show you how I learned when I was in college. A line has a degree of 1, so it's just a straight line. Okay, a quadratic, has a degree of 2. So this is what I call has two waves, or it's kind of like moving in two directions. I think it's going down and then up. See, this one's just going in one direction. A cubic has a degree of 3, so it's moving in 3 directions. Ready? Up, down, and up. It's almost like it has, I can call them waves, has 3 waves, up, down, and up. Okay. Or it's moving in 3 directions, okay? So now imagine a quartic. So it has a degree of 4, right? So just think 4 waves. So it has to go in 4 directions, and it is positive, so it has to be rising. So down, and up. Okay? So the degree and the number of waves are going to have a correlation, okay? So I don't need a graphing calculator. I just need a basic shape right now, okay? So let me move this. So a quintic is going to have 5. So it's going to go up, down, up. So that's 1, 2, 3, 4, and then 5. Okay? Now, can you imagine what a 6-degree looks like? Ready? It's going to go down, up, down. That's 3. Up, 4, 5, and then 6. Now, if you compare them to the degree and the number of waves, they should match up, okay? But now also there's another correlation. Look at your odd functions. So odd would be like x, x cubed, x to the fifth. Look at those and look at your evens. Okay, evens would be like 2, 4, and 6. There's a correlation there as well. Okay, so no matter what, they're all rising. See how at the end, all the arrows move up? So that's a correlation. And then look at your odds. Your odds started down low and they're moving up. See, down low and then up, down low and then up. And then your events basically have like a U shape. There's some action going on here in between, but it's basically like a U shape. See, starts off here, there's something going on, and then it still goes up. Okay. So here's where we have to concentrate. Okay, so I'm going to work with the odds first. Okay, so with the odds, just focus on the part that it starts and ends. Focus on the part where it starts and it ends. Ignore the part in the middle because depending on the function, there's going to be a lot of stuff going on in the middle, but focus at where it ends. So starts and ends. And of course, there's stuff in the middle, okay? So for the odds, they pretty much have the same basic shape. Start at the bottom and then rise, okay? And things happen in between. In this one, the first one, nothing is happening, but in the other ones, there will be things happening in between, okay? And then for the events, same thing, concentrate on the ends. They both rise. There's things happening in between, but they both rise. Okay, so just think they kind of have a basic U shape. Okay, and there's stuff in between. Again, it's going to keep changing depending on the degree, but just concentrate on the ends. Okay. All right, awesome. All right, moving on to the next part. Okay, for the other thing that you need to know is we're going to be writing domain and range and interval notation. Interval notation means you're either going to have parentheses, and of course, you're going to insert, your x and y value, or you're going to have brackets and you're going to insert your x and y value. Okay, or it could be a combination of those. So it might be like, say, parentheses and a bracket, or a bracket and parentheses, okay? It could be a combination of those. But this is interval notation. Now, if you're wondering, when do we use parentheses versus brackets? You use parentheses if your number is infinite, okay? And I'll explain what that means. Infinite means the line keeps going, it doesn't stop, okay? It might go to positive infinity or negative infinity, and that's when we use parentheses. When do we use brackets? If your number is finite, okay? Basically, don't use it for positive infinity or negative infinity. Finite means it actually ends somewhere or starts somewhere. So an actual number. So like 2, 3, 4, 5, 6, I don't know, 10, 20, 100. Those are actual tangible numbers. Like if somebody tells me, how old are you? I can give them an actual number. Okay. If somebody says, I don't know. How far is the sky? I don't know. Infinity. It's not tangible. We know it. There's no end to it. Okay. And I'll show you how to use these in a minute. Okay. But we use them for domain and range. All right. Awesome. Okay. So knowing these basics, now we can get started with filling out our charts. So let's do that next. Okay. This is in your textbook. Or if you're using in the notes, you can just go ahead and read this on your own. I will translate it to something easy, but if it helps you, you can go ahead and read that. Okay, so I'm going to move down and we're going to fill out this chart. Okay, so the first thing I'm going to do is we have here our 6 functions that I gave you. Right underneath, I'm just going to write the names, okay? So let's do that. Okay, so we have linear, quadratic, cubic, quartic, quintic, and 6-degree polynomial function, okay? All right, you should basically know the graph that belongs with the name or the name that belongs with the graph. So if I say cubic, you should know exactly what graph I'm talking about, okay? So you should know it, okay? And I expect you to know it. Okay, so now the graph, we're just going to do a quick graph. So remember, linear, and I'm going to do this in black, I apologize. Okay, so a linear graph basically looks like this. A quadratic graph looks like this. And for cubic, you're going to be surprised, but what I'm going to write is actually this. Okay, quartic, this, quintic, this, and 6-degree, this. And I keep saying this, but so, and the reason why I drew these shapes and I just alternated, because remember I wanted you to concentrate on the ends. So even though we have activity going on in the middle, okay, in this case we don't, but I'm just going to put it anyways. I don't really care, okay? I already taught you the little shortcut on how to get the waves, okay? So we concentrate on this portion, okay? So basically, the odd functions are going to look like this, okay? Same thing with the events. Remember, they basically have a U shape, or you can say a W shape. There's action going on in between, but they basically have this shape in general, okay? So now let's fill out our domain and our range, okay? Remember, when you fill out your domain, you're looking at your x values, okay? So here we go. Let's start with the very first one, linear. So your domain as far as x's is how far to the left do you go? Just think about that. How far to the left? Well, do you notice that your graph keeps going down and it'll never stop? So the further you go down, it keeps going to the left. So what happens is there's no restriction. So we're going to put parentheses because it's going to go as far to the to negative infinity. And when you look at it to the right, because that's the positive, how far does it move to the right? Well, notice your graph keeps rising, and if it's going to keep rising, it's going to keep moving to the right. So guess what? There's no restriction there either. Okay. Now, if you're wondering how do we write this, well, remember, because we used the infinities. And by the way, you could just put infinity or positive infinity. That's up to you. We always put our minimum here and our maximum value. Okay. So our minimum and our maximum. So obviously negative infinity is smaller than positive infinity. So we always write it this way. And it has to have parentheses because remember, those are infinite. So if we wrote our domain for our linear function, we can write it for cubic and quintic because they'll have the same domain. So negative infinity and positive infinity. Negative infinity and positive infinity. Remember, if you don't write the positive, it's automatically assumed, okay? All right, let's move on to the next part. All right, now let's talk about end behavior, okay? So end behavior. As x approaches positive infinity, where does your graph go? And I always ask that, where does your graph go? Because f of x is the same as y, okay? So ready? As x approaches positive infinity, you're looking at the graph on the right side. So the further I go to the right, where is your graph going? Your graph is moving up. How far up? All the way to positive infinity, okay? Now, as x approaches negative infinity, that's the left side, because on the number line, the further you go to the left, you're going to go all the way to negative infinity. So now you're looking at it on the left side. So the further I go to the left, where does your graph go? Your graph is going down. How far down? Negative infinity. Okay? Now, here's a correlation. Look at your domain and look at your end behavior. The further I go to the left, your graph goes to the bottom. The further I go to the right, your graph goes to the top. Okay? So they should somewhat match. Okay? And I say somewhat because you might see something different, and I'll show you. Okay? So now, ready? Repeat the same thing for all the odd functions. So this should be positive infinity, negative infinity, positive infinity and negative infinity, because obviously the same thing's happening. Okay. Awesome. Okay, now we're going to try the range. Okay. Remember, range has to do with your y values. And, well, is there any restriction on your y values? How far is your graph going down? Guess what? Your graph never stops going down. How far is your graph going up? Same thing. Your graph doesn't stop going up. So same thing. There's no restriction. Okay. Negative infinity and positive infinity. So what you've learned is there's no restriction on x's and y's. As long as your graph is continuous, so are the domain and range. Okay. And remember, these are your y values. So I apologize earlier, but your y value should match up with your end behavior. Okay. All right, now we're going to do the evens. Okay. So evens. You're going to see there's a different shape, so something's going to change here. Okay. So let's talk about domain. It is a U shape, but what's happening is it keeps moving up, and at the same time, well, let me show you. It's a U shape, but the further it moves up, it's also, look at my hands, it's also expanding towards the left and the right. And since it keeps moving up and it doesn't stop, that means it should also have a negative infinity and positive infinity on the domain. There's no restriction. This graph is going to keep going forever, so there's no restriction here. Now look at your range. There is a restriction on your range. Look at your graph. On both sides, they go up. They never go down because these are all positive. So if you're wondering how far down did it go, well, if you would have graphed it on a graphing calculator, you would have known it would have stopped at 0, 0. That's the vertex. So this is your y. So you want to concentrate on 0. So this time it is finite. So what we're going to write is 0. That's our minimum. Okay. Our maximum is negative infinity, and we have to put parentheses. It doesn't stop going up, so that's our maximum, but it does stop going down. It stopped at 0, and that's our finite. So it has to be brackets, okay? All right, with that said, you can repeat these two values here and here. So negative infinity, infinity. Notice all of these are the same. What that means is there's never a restriction when it comes to the x's. When it comes to the y's, there's a restriction here. Okay, it goes as far down as 0, but it doesn't stop going up. Okay, awesome. All right, now look at our end behavior. Okay, ready? This one's going to be super easy. The further it goes to the left, where does your graph go? So the further I go here, where is your graph going? Up. How far up? Positive infinity. The further I move to the right, where does your graph go? Your graph is going up, and it goes as far as positive infinity. So on end behaviors, on the ends of them, they're both going up, and they're both going all the way to positive infinity. So in this case, all of them would be positive infinity. Okay? All right. Hopefully you understood these, which will make the second chart a lot easier to fill out. Okay? All right, let's move on to the next one. Okay, so this chart is going to be very similar to the previous one, but if you look at your functions, these are all negatives. So what happens is they're a reflection of the previous. So now instead of my graph going up, it's going to be going down. Okay, and this is going down because they're a reflection, so it flips down. This is a reflection. Okay, so down, 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 and down. Okay. All right, so here we go. All right, as far as domain goes, just because it got reflected either across the x-axis for the across the y-axis for the odds, guess what? Your domain didn't change. Just because it got reflected across the x-axis for all the evens, it still didn't change. So all your domain is still going to be negative infinity and positive infinity. By the way, If there's no restriction, if you recall, I showed you what another way to write this is for domain. Of course, this is written in interval notation, but what this means is all real numbers. All real numbers. This is a way of writing all real numbers, meaning there's no restriction. It's going to keep going forever. Okay. So negative infinity and infinity. I also showed you that R with the 2 lines going down. Okay. So you can just fill out this entire row the same. Okay, awesome. All right. So now when it comes to range, we're looking at our Y values. Okay. So ready? Look here. Let's split it into 2 parts. Let me put my finger this way. The further I go to the left, where's your graph going? Your graph is going up. And the further I go to the right, your graph is going down. So what happens is your graph is still going up and it's going down. So guess what? There's no restriction. It is negative infinity and positive infinity. Okay? Going up, all the way up, going down, all the way down. So all your odd functions should have the same range. So no restriction still on domain, no restriction on your range. So domain and range, no restriction, all real numbers. All right, what about the evens? The further I go to the left, which by the way, I'm kind of helping you with your end behavior if you think about it. The further you go to the left, where's your graph going? Your graph is going down. The further you go to the right, where's your graph going? Still going down. So no restriction there, but remember your graph is going down. But we're looking at range. Range is up and down, okay? So how far down did your graph go? To negative infinity. So parentheses, negative infinity. How far up did your graph go? Your graph went all the way up to 0 and it stopped at 0, okay? So this is the lowest point on the graph. This is the highest point on the graph. And again, these should repeat. All right, boys and girls, at the same time, I was giving you some hints for end behavior. So let's fill out end behavior. All right, so here I talked about how the further you go to the left, your graph is moving up. How high up? To positive infinity. So for here, it'll be positive infinity. Remember, x is negative infinity towards the left. Your graph is going up. Okay, over here now, the further you go to the right, your graph is going down. How far down? Negative infinity. Okay, so notice the difference between this chart and the previous one. Okay, so again, you can fill out all the evens because they will be exactly, all the odds because they will be exactly the same. Okay, for this one is super easy, the evens. All right, boys and girls, as x approaches positive infinity, that's your graph on the right side. Where's your graph going? Your graph is going down. How far down? Negative infinity. As x approaches negative infinity, that's towards the left. Now you're looking at it towards the left. How far down is your graph going? All the way down to negative infinity. So for these, it's negative infinity. Okay. All right, awesome. Now we're going to move on to the next part. So as long as you understand this, it'll make things a lot easier. Again, if you're still having trouble, come and check in with me or use Desmos or your graphing calculator, okay? But please reach out for help. Awesome.